Now, hello student. I am going to discuss with you first chapter, electrostatic and field. So first of all, I am going to discuss with you what is electrostatic. Electrostatic is the branch of physics which deals with the electric charges at rest, means static charge. It deals force, field and potential arising from the static charge. Now, what is electric charges? It was observed that when two glass rods rubbed with silk are brought close to each other, they repel each other while the glass rod and silk attract to each other. This is due to bodies acquire electric charges during rubbing. Now next, frictional electricity. Now what is frictional electricity? The phenomena of the acquire electric charges by friction is called frictional electrification, and the bodies are said to possess frictional electricity. This is also called triboelectricity. Rubbing of insulator Now next, rubbing of insulator. But what is the meaning of rubbing of insulator? Now, rubbing of insulator causes the transfer of charges from one body to another body. Transfer of charges from one body to another body. Now, the body which lost electrons gets the positive charges, and the body which gains electron negative charges. For example, when glass rod rub with silk, glass rod lost electrons and becomes positively charged, and silk get electrons and becomes a negatively charged. Okay, for note purpose, you can see the triboelectric series in the list of rank material according to their tendency gain or loss of electron: glass, silk, cotton and ebonite and PVC. Now wool, paper, okay, amber and polythene. So for the series of positive to negative, good white silk produce clean, attractive, elegant plastic pens. Okay. Now next, from the above figure we can understand that the glass move positively wool or silk. नोट, कंडक्टर कैन नॉट बी चार्ज बाई फ्रिक्शन. हम लोग कंडक्टर को फ्रिक्शन से चार्ज नहीं कर सकते. नाउ नेक्स्ट, व्हाट इज इलेक्ट्रोस्कोप? एन ऑपरेटर्स यूज्ड टू डिटेक्ट द प्रेजेंस ऑफ एन इलेक्ट्रिक चार्ज, जिससे हम पता करेंगे कि इलेक्ट्रिक चार्ज है कि नहीं. व्हेन द चार्ज ऑब्जेक्ट टच द मेटल knob at the top of the now next, electroscope rod leaves the electroscope. ठीक है, diverge the degree of divergence in the indicator amount of the charge. बेटा ये डायग्राम से कुछ क्लियर है. ये हमारा गोल्ड लीव होगा, ये ग्लास विंडो होगी, मेटल नॉब, मेटल रॉड. ठीक है. What are the some basic properties of electric charge? I am going to discuss with you one by one basic properties of electric charge. Now, first properties is there are two types of charge. Everyone know, positive and negative. Like charge repel and unlike attract to each other. Charge is a scalar quantity, beta. Now, fourth property, charges are additive. Suppose we have several number of charges like Q1, Q2 and Q3. Then total charge the system of is Q1 plus Q2 plus Q3 dot 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 plus Qn. Now, fifth property is everyone know, charge is conserved. It is not possible to create or destroy a net charge, that is the total charge on an isolated system is always conserved. Now property number 6, charge is quantized. Charge of body is an integral multiple of charge of electron, that is the basic charge is equal to the electronic charge, like E is equal to 1.602 into 10 power minus 19 coulomb. Therefore for numerical we shall take Q is equal to plus minus Ne. Listen beta, I'm going to discuss first numerical based on electric charge. Now problem is how many electrons are present in 1 coulomb of charge. So beta, you have used the formula Q is equal to Ne, therefore N is equal to Q by E. Put the value of charge is 1 coulomb and value of 1 electron 1.6 into 10 power minus 19 coulomb. Coulomb cancel out. After calculation we have value 6.25 into 10 power 18. that is 1 coulomb means 6.25. 1 coulomb means 6.25 into 10 power positive 18 electrons are excess. Similarly, we can say for plus 1 coulomb means 6.25 into 10 power 18 electrons are deficient, because Q is equal to plus minus Ne. So you can take 1 positive minus 1 coulomb for 1 negative 1 coulomb. Now second problem NCERT example से बताइए. Now next second one is, if 10 to the power 9 electron move out a body to another body every second, how much time required to get total charge 1 coulomb on the other body? So solution beta, 1 coulomb value is 6.25 into 10 to power 18 electrons. Time to move out into 10 to power 9 electron is 1 second. So we can use the time to move out 1 electron 1 by 10 power 9 second. Therefore, the time to move out 6.25 into 10 power 18 electrons. Now 6.25 into 10 power 18 multiply by 1 upon 10 power 9 second. After calculation, we have 198.18 year. Now friends, I'm going to discuss with you next topic, Coulomb's law. Very important topic. बेटा से concept देख लेना, एग्जाम में concept से क्वेश्चन आते हैं आपके यहाँ से. Coulomb's law, it states that the electrostatic force between two stationary electric charge is directly proportional to the product of two charges and inversely proportional to the square of the distance between them. ये दो चार्ज है बेटा, मैंने r डिस्टेंस पे सेपरेट किया. Now force of attraction between them, F is directly proportional to Q1 into Q2 product के, and F is inversely proportional to square of distance, where after removing the proportionality, you can take in place of proportionality sign 1 upon 4 pi epsilon Q1 Q2 by R square, where epsilon is a constant called permittivity of the medium. If the charges are placed in vacuum air, for epsilon, you can take epsilon is equal to epsilon naught. So in place of epsilon, you will remove, you can replace epsilon to epsilon naught, where epsilon naught is the permittivity of free space and whose value 8.85 into 10 power minus 12 coulomb square per Newton meter square. You can also put the value of 1 upon 4 pi epsilon naught 9 into 10 power 9 Newton meter square per coulomb square. The note, very important notes for you. You can take, if Q1 is equal to Q2 is equal to 1 coulomb, R is equal to, and R is equal to 1 meter placed in vacuum. Vacuum means you can take T constant overall is equal to 1. 1 coulomb is, and after putting the value, you will get the value F is equal to 9 into 10 power 9 Newton. That is 1 coulomb is defined as the charge width when placed in free space at a distance of 1 meter with an equal and similar charges will repel to force 9 into 10 power 9 Newton. So next topic, relative permittivity. So what is the relative permittivity? I'm going to discuss with you relative permittivity. Relative permittivity of a medium is the ratio of permittivity of the medium to the permittivity of free space. Beta ER is equal to epsilon upon epsilon naught. ठीक है, और after cross multiply we can write epsilon is equal to epsilon naught into epsilon r. Therefore F MED is equal to 1 upon 4 pi epsilon naught into epsilon r into Q1 Q2 upon r square. Force in air upon ER. ER means relative permittivity. Therefore epsilon r is equal to F air upon F medium. So relative permittivity also called dielectric constant. So we can say that dielectric constant. Now next, one very important note for you. From the above equation we can also write F MED is equal to F air upon epsilon r. For a medium, epsilon r is greater than 1, that is the F medium less than F air. Now one problem based on relative permittivity or based on Coulomb's law. 2 point charges placed at a distance r in an air experience a certain force, then what is the distance at which they will experience the same force in a medium of a dielectric constant K. So we can write the formula of force according to Coulomb's law, 1 upon 4 pi epsilon naught Q1 Q2 upon r square is equal to 1 upon 4 pi K epsilon naught Q1 Q2 by r square in a medium. All are same, 1 upon 4 pi epsilon naught cancel out, Q1 Q2 also cancel out, so remaining part 1 by r square is equal to 1 upon capital K. 1 upon r square in a medium. Therefore r square medium is equal to r by k. So rm is equal to square square cancel out root k. R medium is equal to r upon root k. Listen now next problem written here. 2-point charges placed at a distance r in a air exert a force F on each other. The value of the distance r at which they experience force 4F when placed in a medium dielectric constant K is equal to 16. So we have 4 options. A is equal to r, B option r by 2, C option r by 4 and D option r by d. Simple, you can use the formula. F is equal to 1 upon 4 pi epsilon naught q1 q2 by r square. And now 4F cross multiplication, sorry, you can multiply equation by 4. We have 4F is equal to 1 upon 4 pi into 16 epsilon naught square q1 q2 by r square. Dividing 1 by 2, you will get the value r is equal to r by 8. You can also try it here because in your question already written experience 4F when a place at a medium and k is equal to k for 16. So when I will take in place of 4F now k is equal to 16. In place of k you can write 16 directly. Now next beta, Coulomb's law in vector form is very easy. Coulomb's law in vector form, you can draw origin x-axis, y-axis. This is a position vector r1 vector, position vector r2, B point and A. You can join the force acting on a charge q1 due to q1 force on q1 due to q2 f1 to 1 upon 4 pi epsilon naught q1 q2 upon r square r cap 1 2, where r cap 1 2 is the unit vector q2 to q1. Similarly the force acting on q2 due to q1, बस आप कुछ नहीं करोगे. In 1 2 you can write 2 1. Now next, since r1 cap 1 2 is equal to minus r1 cap 2 1, because direction is opposite, it shows opposite direction. It equal in magnitude but opposite direction. Note, Coulomb's law holds good only for point charges. The direction of force is always along the line joining the 2 points charges q1 and q2. Hence the force is called central force. Now we have one more question. An electron and proton are separated by a distance r. Compare the magnitude electric force with the gravitational force between them. So beta, first of all you can write the magnitude of gravitational force and electrostatic force. So F is equal to 1 upon 4 pi epsilon naught, both having charges E by r square, and gravitational force F is equal to capital G mass of proton mass of electron by r square. So we can write here 1 upon 4 pi epsilon naught E upon r square, capital G MP Me upon r square, where MP is mass of proton, Me is mass of electron. After calculation we have value 2.4 into 10 power 39. So F is equal to 2.4 into 10 power 39 into Fg. Therefore it is clearly for electrostatic force is much greater than gravitational force. Now next, force between multiple charges. The electrostatic force between two charges is not attracted by the existence of the other charges, and the total electrostatic force on a charge vector is force due to the other charge. This is the superposition principle. So beta, you can directly write F1 is equal to F12 plus 1 3 plus dot 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 plus F1n. So I'm going to discuss with this concept with one numerical, consider 3 charges q1 q2 and q3 each equal to q at the vertices of the equilateral triangle of side L. What is the force on charge q with the same sign as a q placed at a centroid of the triangle shown in figure? तो आपके लिए प्रॉब्लम है, इसे सॉल्व करो बेटा. इसको सॉल्व करने पे आंसर आपके 0 आएंगे. आप कमेंट बॉक्स में लिखो इसके आंसर सॉल्व करके. ठीक है. नाउ नेक्स्ट प्रॉब्लम, 12 equal charges q are situated at the corner of a regular 12 side polygon for n one of each numeral of clock face. What is the net force on a test charge q at the center? Now question B, suppose one of 12 q is removed the one at 6 o'clock, What is the force on Q? Explain your reasoning carefully. Now C, now 13 equal charges Q are placed at the corner of the regular 13 sides polygon. What is the force on the test charge Q at the center? Answer for A beta 0. Answer for B, F is equal to 1 upon 4 pi epsilon naught Q by R towards the missing charge, and C is equal to 0. You can try to solve it. Now next concept for electric field. What is electric field? So it is the region around the electric charge where an electric force is experienced on the another charge. जब हम लोग एक के प्रेजेंस में दूसरे के थ्रू फोर्स को हम लोग फील करते हैं बेटा, इट इज कॉल्ड इलेक्ट्रिक फील्ड. नाउ नेक्स्ट कंसेप्ट, electric field intensity at a point E. Electric field intensity at a point is defined as the force experienced on the unit positive test charge placed at a point, whereas Q1 charge is placed at a distance r from point P. Let the small test charge delta Q is placed at P. Given force experienced by test charge is given by F is equal to 1 upon 4 pi epsilon naught Q delta Q by R square. Therefore, the force experienced on a unit positive charge is E is equal to F upon delta Q. So, E is equal to 1 upon 4 pi epsilon naught Q by R square. Now, next, electric field lines or electric lines of force. So, it is the path along which unit positive charge would move if it is free to do so. The tangent at any point on the line force will give the direction of electric intensity at that point. What are the properties? It starts from the positive charge and end from negative charge. Two field lines can never intersect to each other. If they did, the field at the point of intersection will not have a unique direction. Electrostatic field lines do not form any closed loop. ये कभी क्लोज लूप नहीं बनाएंगे, कभी ये दोनों एक दूसरे को इंटरसेक्ट नहीं करेंगे बेटा. इट स्टार्ट फ्रॉम पॉजिटिव चार्ज और एंड जहां पे खत्म होंगे उनको क्या बोलोगे आप? नेगेटिव चार्ज. नाउ नेक्स्ट, uniform electric field can be represented by parallel lines. Field lines due to some simple charges configuration. Q greater than positive for negative, and here is both positive here, and both charges positive and negative. Here is both positive, greater than only positive for negative, positive, negative, and both are positive here. Now next topic is electric dipole. I am going to discuss with you electric dipole. बेटा क्या होती है इलेक्ट्रिक डाइपोल, अभी हम डिस्कस करेंगे. Electric dipole, two equal and opposite charges separated by a small distance is called electric dipole. Here is two charges plus Q and minus Q are separated by distance 2a. It is called electric dipole. Now next concept, dipole moment. The strength of the dipole is measured by quantity is called dipole moment. Dipole moment P is equal to Q into 2a. I have taken here 2a, this separation between them. ठीक है. It is a vector quantity. Dipole moment बेटा vector quantity whose direction from the negative to positive charge. Exam में बहुत important है. What is the direction of dipole moment? Very very important line. Direction from negative charge to positive charge. Unit of electric dipole moment is coulomb into meter. Now next concept, electric field due to a dipole. ठीक है, और हम लोग कैलकुलेट करेंगे बेटा इलेक्ट्रिक फील्ड ड्यू टू अ डाइपोल. यहाँ पे एक डेरिवेशन होगा, ठीक है, उस डेरिवेशन को देखेंगे. एट द एक्सियल लाइन ऑफ डाइपोल, अगर ये किसी एक्सिस पे बात करोगे बेटा, यहाँ पे नेगेटिव चार्ज है, यहाँ पे पॉजिटिव चार्ज क्यू है. एक सेंटर मैंने ओ लिया, टू चार्जेस आर सेपरेटेड बाय अ डिस्टेंस 2a बट हाफ एरिया a एंड a अगेन, एंड फ्रॉम सेंटर o after you can take the distance small r, take a point P where we have to find the electric field. Now going to find out the electric field at a point P which is at a distance r from the center of the dipole on the axial line. EF at a point due to positive charge, so you can use the formula electric field E is EB, ठीक है, 1 upon 4 pi epsilon naught Q upon r minus a square P. E P at P due to minus charge, यहाँ बेटा प्लस के थ्रू लिया मैंने, एक माइनस के थ्रू लिया, सो रिजल्टेंट EB प्लस EA अकॉर्डिंग टू A अकॉर्डिंग टू B, दोनों को आपने ऐड किया. आफ्टर कैलकुलेशन वी हैव दिस वैल्यू. After calculation you can get now E is equal to QP upon 4 pi epsilon naught in bracket 4 ra upon r square minus a square to whole square is equal to 2q into 2a r p upon 4 pi epsilon naught r square minus a square to whole square. After calculation we have this value. For an ideal dipole, r square much greater than a square, so a square can be neglected. Therefore, the E axial is equal to 2p upon 4 pi epsilon r cube. P p cap is equal to 2p upon 4 pi epsilon r cube. But it is a very important formula for finding the numerical, and you will write the result for electric field at a axial. So at axial line, Eax is equal to 2p upon 4 pi epsilon naught r cube. P vector is equal to 2p upon 4 pi epsilon naught r cube. Now its second point at the equatorial line of a dipole perpendicular bisector. So bit of it's in this derivation we are going to find out the electric field at a point P. Our aim to find electric field at a point P. तो यहाँ पे आपने A point B point लिया, separation between two charges minus Q and plus Q, 2A, and take a point P. We are going to find out electric field at a point P, which is the distance r from the center of the dipole on its equatorial line. Magnitude of E at P due to positive charge EB is equal to 1 upon 4 pi epsilon naught Q by under root r square plus a square to the whole square. So electric field 1 upon 4 pi epsilon naught Q by r square plus a square, direction of B to P. Now next, magnitude of E at P due to minus charge EA 1 upon 4 pi epsilon naught Q upon under root r square. ठीक है, और next EA is equal to 1 upon 4 pi epsilon naught Q upon r square plus a square. Since the magnitude of EA and EB are same, बेटा देखो दोनों के magnitude same है. The vertical components ठीक है cancel to each other and the horizontal component only exist. So resultant E at P EA cos theta plus EB cos theta minus P cap. So E at P is equal to 2EA cos theta minus P, since EA is equal to EB. Now next, also here cos theta is equal to A upon r square plus a square to the power 1 by 2. Therefore E vector is equal to 2 upon 4 pi epsilon naught Q by r square plus a square into A by r square plus a square power 1 by 2 minus P cap. After calculation we have the value E is equal to P upon 4 pi epsilon naught r square plus a square 3 by 2 minus P cap. For an ideal dipole, r square much greater than a square, so a square can be neglected. Therefore E equatorial is equal to P upon 4 pi epsilon naught r q minus P cap. So minus P vector upon 4 pi epsilon naught r q. But it is a standard result for finding the value of electric field on equatorial. Now next, dipole in external field. How I will find the dipole in external field? So we have two cases. For first, in a uniform electric field. बेटा ये कोई uniform electric field है, मैंने यहाँ पे किसी को एक dipole मैंने लिया है, having dipole length is 2a, two charges plus q and minus q separated by a distance 2a. Electric field due to minus q charge minus q into E. Electric field due to positive charge q plus q into E. Angle with electric field is here theta. Now net force F is equal to minus QE plus QE, therefore net force is 0. Now torque is equal to force into perpendicular distance, so torque is equal to QE 2A sin theta, therefore tau is PA sin theta. Now tau is equal to P into E. So it is a result for an uniform electric field dipole in an external field. Note, when a dipole is placed in uniform electric field, the total force is 0. There is no translational motion. Torque will be 10 to again the dipole with the field E. When P is aligned with E, the torque will be 0. Now second case is in a non-uniform electric field. In non-uniform electric field, there is a torque and net force on dipole, thus the dipole has the rotational and translational motion. हम नेक्स्ट डिस्कस करेंगे बेटा इलेक्ट्रिक फ्लक्स. व्हाट इज इलेक्ट्रिक फ्लक्स? Electric flux. I am going to discuss with you the concept of electric flux. Electric flux through an area is defined as the total number of electric field lines passing normally through the area. The flux through an area is given by product of area and the component of electric field perpendicular to the area parallel to the vector. So phi is equal to integral E cos theta dA. So ये d area vector, electric field, direction of electric field E, and is a theta angle between them. Electric flux through small area dA is given by d phi E cos theta dA. So very for small cos theta is equal to 1, and 1 gives the value for cos 0 degree. So E into dA, the total electric flux through area A is phi is equal to integral E into dA. What is the unit of Newton meter square per coulomb? Now I am going to discuss with you one problem for you. You can solve. Consider an uniform electric field E is equal to 3 into 10 power 3 I cap Newton per coulomb. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to YZ plane? What is the flux through the same square if the normal to its plane makes 60 degree angle with the axis? But you can solve. It's a very simple question. आप solve करो, comment box में लिखो. Now next topic for you, continuous charge distribution. Continuous charge distribution, very very important for you. Linear charge density lambda, everyone you know, dq upon dl. Surface charge density represented by sigma is equal to dq upon dA, and volume charge density rho is equal to dq upon dV. For P dV is equal to volume charge density, sigma dA is equal to dq for area charge density, lambda dl by dq is the linear charge density. It is a very simple, and you can learn three very important result. Lambda is equal to dq by dl for linear charge density, surface charge density sigma dq by dA, volume charge density rho is equal to dq by dV. Now next concept, next topic for you, Gauss law. I am going to discuss with you what the concept of Gauss law. Gauss law states that the net electric flux through the closed surface is equal to the 1 upon epsilon naught times the net charge enclosed by the surface. I am going to prove it. A positive charge is located at the center of the sphere. But I can take a sphere of having positive charge plus q at the center. The magnitude of the electric field everywhere on the surface of the sphere is same and is direction perpendicular to the surface and area vector. So therefore E is equal to 1 upon 4 pi epsilon naught q by r square. Q by r square. Therefore total flux through the surface phi is equal to phi integral E dA. Use this formula. Now phi is equal to phi integral E dA. Therefore integral phi E dA. Since E and dA are in same direction, so phi is equal to integral phi E dA 1 upon 4 pi epsilon naught q by r square. Integral of phi into dA 1 upon 4 pi epsilon naught q by r square into 4 pi r square. Therefore q by epsilon naught. There is a standard result. So it is clear that Gauss law, electric flux is 1 upon epsilon naught times of the charge q, positive charge q at the center of the sphere having radius r. Note a very important point according for Gauss law. Gauss law is the true for any closed surface irrespective of the size and shape. Now one more problem. A square surface with side length 3.7 mm is located in a uniform electric field with a magnitude E is equal to 2400 Newton per coulomb as shown in the above below. What is the electric flux through the surface assuming that the normal is directed towards? So the angle already given. So we have the formula phi is equal to EA cos theta. So already given the value of A and E or cos 150. You can put the value and get the result. Now next problem for you. A cube with edge length 0.90 meter is located in the XYZ space as shown in the figure below. If the uniform electric field in a space is given by minus 400 J cap Newton per coulomb, what is the electric flux through the right faced cube? We have same formula phi is equal to EA cos theta. you can put the EA cos theta, you will get the value minus 3.24 Newton meter square per cube. One two problem for you, you can solve. Problem number 7, 8. A charge q is placed at the center of cube. What is the flux through the face of the cube? And one more question for you. A charge q is the back of the corner cube as shown in figure. What is the flux of it through the shed edges? Now next, note, Gauss surface, an imaginary surface enclosing the charge of the charge distribution, is called Gaussian surface. A Gaussian surface can be a surface of any shape. What is the application of Gauss law? We have several application of Gauss law. For now, first, electric field due to an infinity long straight uniformly charged wire. Consider an infinitely long straight charge wire of linear charge density lambda. To find the electric field at a point P, at a distance r from the wire, consider the Gaussian cylinder of radius r and length is L, coaxial with the wire. Apply the Gauss law of Gaussian surface. You can use the formula line integral Gse dA. So Q enclosed upon epsilon naught. Therefore, you can write integral total surface EA dA plus BS EDA plus CS EDA total line integral lambda dl upon epsilon. Say equation number 1. For top surface and the bottom surface, E and ds are perpendicular. E and ds are perpendicular to each other and flux through the surface is 0. For the curved surface, E and ds are parallel. Therefore, line integral CS is equal to EDA integral lambda dl upon epsilon naught E CS dA lambda epsilon naught dl, this E 2 pi RL lambda L by epsilon naught. So E is equal to lambda upon 2 pi R epsilon naught, where n is the unit vector. You can place, also you can use n vector, n cap. Now second application, electric field due to a uniformly charged infinite place sheet. You can same process you can solve and direct you can learn result here. E is equal to sigma upon 2 epsilon naught. E vector is equal to sigma upon 2 epsilon naught n cap, where n cap is a unit vector perpendicular to the sheet. Electric field due to two parallel line charge at infinite sheet. Same procedure for here. You can just learn directly. E inside is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon. Therefore, sigma upon epsilon naught. Direction from the positive charge plate to the negative charge plate and the uniform anywhere inside the plate. Now, third properties is electric field due to a uniformly charged spherical shell of a radius r and the surface charge density sigma. So first point, field outside the cell. So beta you can learn direct result for numerical. After solving for this, you can get the value E out is equal to r square sigma upon r square epsilon naught. Now field on the surface of the cell, E surface is equal to sigma upon epsilon naught. Field inside the cell, third property, field inside the cell, here is third property. After applying the Gauss law, line integral Gauss surface EDA is equal to Q enclosed upon epsilon, therefore it is 0. Therefore E inside is equal to 0. Very important points, the electric field is maximum at the surface of the cell. Electric field decreases as a 1 by r square outside the cell. Electric field is 0 inside the spherical cell, hence the person inside a car does suffer than the outside during the lighting. Variation of EF and cell R is graph. You can see, आप देख सकते हो किस तरह का ग्राफ यहाँ पे शो हो रहा है E और F के अकॉर्डिंगली इलेक्ट्रिक फील्ड कैसे चेंज होगी बेटा R के थ्रू. Now previous questions. Gauss theorem is useful in determining the electric field when the source distribution has the symmetry. The electric field intensity at one distance r from the uniformly charged infinite plane sheet of the charge proportional to r 1 by r square proportional to r square independent of r. A thin spherical cell of radius ना बेटा प्रीवियस क्वेश्चन फॉर 1 मार्क लाइक इंडिपेंडेंट ऑफ दिस क्वेश्चंस, 2 मार्क्स से बेटा क्वेश्चन ऐसे होंगे. A thin spherical cell of radius capital R is the uniformly charged to the surface. Charge densities using the Gauss theorem derive expression for the electric field produced outside the cell. तो बेटा ये आप ये छोटे छोटे क्वेश्चन इसकी प्रैक्टिस करोगे आप 2 मार्क्स की इधर दिए हुए. Two plane sheet of charge density plus sigma minus sigma are kept in a air shown in the figure. What is the electric field inside at the point A and B? ठीक है. The idea of electric field lines is like this question. For 1 marks, give any two properties of electric field line. Force state Gauss law's theorem. So a point charge plus q coulomb is at the distance this directly above the center. I have already discussed the all concept in above. You can see you can solve also these questions for very important for you. Now match the column for you A and B. You can just match it. 2005 questions. The electrostatic force per unit charge is क्या करोगे. So define the electric dipole moment. Write an expression for a torque acting on an electric dipole placed in a uniform electric field when it will become a maximum. That type question will prepare. Now but the first chapter is completely completed.